Welcome everyone to another Better Build Prep webinar. My name is Adinda. I am Customer Success Manager at AMIS, and I want to thank everybody for joining us today. My colleague Chris today will talk a little bit more about AMIS Runtime. But for those who are unfamiliar with our software, we'll have a Q&A at the end of the webinar where you can ask all your questions. And then for those who are familiar with the software, please feel free to share feedback or ask any questions as well. We're always open to learn and improve our software, so definitely do so. And also, we'll make sure that you will receive the presentation at the end of the webinar as well. So yeah, without further ado, Chris, the floor is yours.
Right. Thanks, Adinda, for the introduction. And also from me, very much welcome to this new webinar. The first one which is specifically dedicated to AMIS Runtime, meaning to our scriptable solution or automation solution for nesting. That is. I hope everybody can see my screen at this point. Could you confirm? All right, good, great. Thanks. Oh, I even got a thumbs up. Thank you. So, what will we be talking today? That is, first of all, setting the scene a bit. Let's say what does build prep often look like today? Meaning, what do you maybe or probably run into when you're doing your build preparation? And then most of the time we will be talking, of course, about AMIS Runtime itself, what it can do. Thereafter, you will be so convinced that AMIS Runtime is something you need, so you will want to know how to get started immediately, which is what we explain at that moment. We'll briefly mention the pricing of AMIS Runtime, and thereafter you have some time for questions. I would say please bring them on, although I can imagine with this broad topic that it might be difficult to come to very concrete questions immediately, which is why we're anyway available anytime to support you in that, or to support you with any question related to AMIS Pro or Runtime. Then we have a little recap, and that should then obviously, let's say, be the most of the presentation already. Good. Meanwhile, I'm already opening one of our batches here, which actually does take quite a while because I'm running this, as always, from my laptop, meaning it's just a normal laptop. There's nothing heavy about it, which means in combination with a Zoom presentation, that actually sometimes takes a little while. Because, as I said, what I first want to look into is build preparation today and what that looks like. And it looks like it's still having a struggle with the GUI. But there we go. So 2 days ago, I actually prepared a number of batches based upon data coming from an ERP. In this case, my ERP being an Excel form. Now, that's not, I mean, there's quite a few companies that actually still work with the Excel file as the solution. So I have all these parts. I think in total, what's the quantity again? Something like, what does it say here? 8,646 parts, which have a specific due date. Well, I didn't mention it as a due date, but just a figure here to indicate it needs to be ready and on day 5 or 6, and so on. And so what I started doing is basically I started filling up my batches according to the day when it needs to be delivered. Okay, first the ones with the lowest due date, and so on, to keep on filling up whatever I have till then as orders in my backlog. So first of all, I pumped everything I had into my first batch and nested that one, which was this had this one as a result. Of course, a lot of overflow because there were much more parts than actually could fit in one batch. That's okay. Imagine I got 3 machines. I need to put on 3 machines by tonight. And that's okay. So I started filling up this one. Then I used, of course, the unplaced function to actually replace the ones which were inside. And in that way, I made, what is it? 1, 2, 3, 4, 5, 6, 7, 8 batches till I was finally finished with all my parts to get those shipped. Now, I made already an AMIS runtime, of course, because that's what it's needed for. I made a short or a small user interface allowing me to have a look at those batches. And those are these 8 batches, and it's basically reading out the JSON export of each of these batches. And so, yeah, nicely divided in the sense that I reach pretty high fill rate. So that as such is good. The density, however, is quite a bit fluctuating. Of course, the last one has less fill rate because that's like kind of leftover parts. Density is fluctuating between almost 15% and going down as low as here 10%, which of course indicates that it's not optimal. By the way, I got a lot of unplaced parts here, but that's just because I worked how you would work manually, meaning you put in your parts one by one, and then you start with the first batch. Of course, you have a lot of remaining parts, but you export that one, and then you continue working with the remaining parts. So this is not worrying in this case at all. So this little interface is something I made in I think half an hour in AMIS Runtime, but it's of course not exactly what it's only meant for. Although we'll come to the function later. Now, that in itself, of course, costed me quite a bit of work. First of all, I had to not only take all the parts in the right sequence, I also had to start filling out for each of the parts actually the number of copies that were needed. The rotations, excuse me, I didn't even bother about the rotations, which are actually defined in my ERP, in my Excel file. They're defined in there, but I didn't even bother to set them here because, well, basically it's a lot of work, right? It's a lot of waste of time. Of course, I did indicate a certain settings for the nesting, and that's how I went about it. Took me hours to just prepare those 8 batches because of all the manual work which is involved there. And let's remember, so we got 8 batches in this way. There I go. We got 8 batches. We got quite a bit of fluctuation in the density. So of course, well, basically we want to do better on that. So what we see in build preparation today, and it's maybe not for everyone the case because, like for example, we work also together with Phasio, which is one of the ERP systems which is quite compatible with AMIS, meaning it allows you to already export the quantities and the rotations. So that's a big difference in workload for the people doing that. And there are of course a couple of other solutions, but basically lots of manual work, and also I'm not able to oversee or to interpret quantities, 8,000 parts, 8 batches. I just don't have the intellectual capacity to deal with that. And I think, to be honest, most people cannot deal with that. And that's, of course, where computers are very good at in general. Also, you're kind of pressed to make decisions. All these parts need to be definitely in for the 5th because otherwise they will be too late. So I'll start with those. Whereas, and that we also noticed here in the overview, by the way, oh, hang on, yeah, that my parts for the 5th fitted in 2.5 batches because in the third one I could already add parts for the 6th and the 7th, which is great, of course, but it might have been much smarter to actually divide those parts for the 6th and the 7th over the 3 batches equally. because maybe there were smaller parts that nicely fitted in the bigger parts, so that you automatically come to a much better density, or a more even density throughout your batches, meaning also, of course, lowering your overall need for batches. So I was only able to work sequentially, because being able to have a view on everything at the same time is impossible. So you're forced to make decisions. And of course, if you're really not having a communication established with your ERP, the problem will be you need to, well, first you're going to load parts, then you're going to say like, there's more fitting. Okay, I'll get some more parts for date number 6 then. Oh, there's still more fitting. I'll take some from the 7, etc., etc. And each time that you finish a batch, you have to report back like, okay, these fitted, these didn't fit, and so on. So that is actually quite error prone. That gives you quite a possibility to make errors, apart from the fact that it's just a lot of work. Same for the rotations and the quantities, as I mentioned. It's a lot of work to actually enter those in there, and of course, it's error prone. So typically, what does this result in? That on a batch level, yes, you're operator dependent, not only in terms of speed, of course, but also in terms of what result you will get, because everybody still has its own secret sauce of nesting, of course. It will be suboptimal, and that's not because you don't have a good operator, or because you're not a good operator. It's just because it's not possible to overview everything. It's repetitive, it's labor intensive, and of course it will end up with higher cost per part, or higher total cost of ownership. The same counts on a workflow level. You're having underfilled builds, you're having too many print jobs, and you see, you miss opportunities to make combinations there. So basically, that's already, of course, where AMIS Pro comes in. That's already where you can start saying like, okay, how can we, for example, already take out this manual work? How can we at least reduce that manual work? And that's where you start scripting. I'll come back with demo and scripting later. Don't worry, there's some real examples in there. But it basically means that you can write a lot of features, a lot of functions that, of course, are not available, or not available yet in some cases in AMIS Pro, that allow you to do some basic manual work. For example, and this could be a very first setup if you start with AMIS Pro, just a script that goes get all this data and all these parts from a certain, what we call then hot folder, from a place where all these parts are stored, and then from some ERP, some Excel files, from CSV file, as I did it, get data on how should they be rotated, how many are there of these parts. I'm already going a bit forward now. Do they need to be shelled or not? Do they need a specific gap distance? Do they need it, etc., etc.? So you'll see we can get much further in this. But step one might be just to say like, okay, go get me that information and fill up my batches. I have an intensive operator review. Maybe I will renest again a couple of times, because the algorithms, the scripts that you wrote might not be finalized yet, but at least you got rid of this manual work. So that might be a first level of let's say, making something out of build preparation, out of workflow preparation with AMIS Runtime. Moving on to the second level, and I think, of course, there's the most potential gain in there. That is to start looking at a problem in a different way. It's no longer about optimizing individual batches. It's about optimizing entire workflows, meaning indeed having a system that doesn't look only to the parts which are needed to the 5th, and maybe already a bit to the parts that are needed on the 6th, etc., but looking at all parts continuously all the time. That also means that we now have a lot of parts we're almost pressing enter for today's batches to be sent to the printer, but then just last minute comes a very important order in there. It doesn't necessarily mean that you have to take the last batch for today and redo that one. No, you can actually easily redo everything again from scratch, because okay, if these are heavy batches, it won't be done in a minute, but you will later on also see that. And well, AMIS Pro is quite known for being quite fast, let's say, in the nesting itself. So it will allow you to, yeah, this last minute order doesn't come in, doesn't mean that you're actually going to lose money on that one, because you have to stuff it in somewhere and then replace something else, and you're busy half an hour in rebatching that whole thing, because you can continuously recombine. Of course, and that implies, I would say, that you can delay your decisions. So it's not like, okay, yes, after a half an hour work, I got batch 5 ready. I'm not ever gonna touch that again, because it's again same trouble. And that's what operators are nowadays tempted to do, because it's just a lot of work, the nesting. So you put that aside and you continue with the next one. And this new order for tomorrow, we'll see about that tomorrow, because it's just impossible to always continuously redo everything. And with AMIS Runtime, that does become a possibility. Now, and then it says, as a last bullet point there, fill builds intelligently. That can mean a lot, of course. And what can it mean? Basically, it's it's a bit difficult, because every time I talk to people who consider installing AMIS Runtime, or who already are building on a workflow, a methodology, a logic, a sequence to start working with runtime, they come up with new ideas, and it's endless, and that makes it a bit challenging, let's say. But some of the examples that we already have heard, and that are just scriptable indeed, relate to, for example, positioning of parts, meaning you have a lot of data on your parts, and you can read it out from either the JSON or the CSV file, or yeah, whatever system. So you have, for example, a lot of information on its size, on its surface, on its volume, not only the boxed volume, but the real volume and the inside volume, etc., etc. So that means that you can start saying like, okay, if my part is this size or volume or whatever, you can start assigning positions to those parts. You can also automatically assign a gap distance, which is also part of the demo, by the way, meaning if a part has certain features, then it should have a bigger gap distance, or a lower gap distance. That's all possible. You can start rotating parts, which means also you can analyze parts, so you can say something about its shape and how it could be positioned. That's perhaps more difficult. And by the way, that's typically a thing that we're still working on within AMIS Pro. So also for AMIS Runtime, it will become easier, because if the function exists in AMIS Pro, it's automatically taken over in AMIS Runtime, which means the access for you as a user, of course, becomes much more easy than when you would have to script this yourself. You can prioritize parts or combine parts. As in the example, you could do that according to due date, but you could also start thinking about, okay, which parts need which post-processing? And wouldn't it be wise to put those together, so that I don't need to afterwards dig out the ones that need to be separately post-processed, etc. But also, of course, depending on the machine you want to print on, that's a given, I would say. So there's quite a few opportunities there as well. You can, of course, and that's, I think, really one of the main things, and one of the main potential gains with AMIS Runtime, is that you can start spreading your parts over different batches. And then I'm not only talking about my parts for just day 5 or day 6, or depending on delivery dates, but it's just that big parts, you don't want just a batch with only big parts, and then the next batch only to be small parts. That's going to have an impact on quality. That's going to have an impact on return on invest, or cost per part in general. So it's logical that you want preferably some good mixes. If you can spread out your big parts throughout different batches, of course, you have the ability to add more smaller parts, and having a neater mix of the two, and so coming to better nests in general. And that even, of course, the example that I've shown before, typically it obviously, I would say it were mixed batches. That's ideal. That's perfect. And there you see also that we have the biggest gains in terms of cost per part when we start mixing intelligently. But even, and we've done some testing with that, with the things like insoles. Of course, with insoles, let's say you got 5 batches of insoles, you're not going to gain 20% if you actually start mixing between the different batches, because they're all quite about the same shape. But we do see gains from 3 to 5%, meaning on average for a not for all technologies, of course, but it means something like 4 to 10 extra insoles per batch, and that directly translates into cost per part. So it's an easy win even for those type of materials. Same with, by the way, with we had some examples with dental applications, all looking 99% the same, of course. And still, yeah, we do see gains there if you start mixing between different batches. You can also start thinking about making sets of parts, combining 3 parts, which should be in a specific position in order to, well, quite often it has to do with the fact that they need to match. So you want them close together, so the impact is very little on accuracy there. Just combine them first, make a nest out of it, or save it as a 3MF, as one 3MF, which allows you to import it into the next batch, etc. All things that you, and that's maybe also it. There's a lot of things that you could do already in AMIS Pro, but it's going to take you time. You're going to have to position your part there. Oh, yeah, this one needs to be a bit there, because otherwise it's going to be affected by the fact that it's close to the wall, etc. Sure, you can do all that, but it's a lot of manual work. If you let a computer do that, it's a matter of well, milliseconds, and you wouldn't feel the extra effort, so to say. You can start thinking about subnesting parts in specific zones in your printer. Not so difficult to script that, actually. You can start thinking about the HP auto rotate. More about that in just a second. And you can continuously renest, of course, which is the idea of, it's not because you finished one batch that it needs to stay finished. Perhaps there's something new coming in that allows you to even obtain better batches, and definitely overall allows you to get better batches. How does that translate into reality, let's say? Well, you have thin parts, thin, long parts, and like drone wings could be a good example. Typically, you have a long dimension over one edge, a long dimension over the other edge, and very little dimension in the third axis. That's something you can know. That's something you can actually have calculated. Or you could start comparing volume to surface, which could also be an indicator there. So there's possibilities enough to actually analyze that part without having to see it, without having to have a look at it. So you detect it automatically, and then you say like, oh, if it's that kind of part, then I want a larger gap distance. I want it not too close to the walls, or I want it in a specific position inside my build box. So that's one example. Another one could be with the very small parts, where you could start thinking about automatically boxing the parts. Say like, okay, I want these boxed per 20 copies in one box, which is square or which is following shape, or with a certain label or text on top. As long as you can quantify it, you can basically script it. So that's an option for that one then. And then, of course, medium parts, non-urgent parts, or other small parts which can be loose. They're perfectly for filling up. They're perfect for actually improving the overall density, so lowering your overall total cost of ownership for the machines. And they will really have a positive impact on the backlog and on the efficiency of your prints. I already mentioned the HP MGF, because I think there's a couple of people in the audience that have these machines. No, actually, no, it's for sure. They've, of course, heard about these, but of course, all the other machines, all the other technologies, of course, in our case, SLS, jetting, and MGF, have their own rules. Apart from that, every person who is busy with nesting has its own secret sauce on top of that. So that makes it even more difficult, perhaps. But there are rules that everybody knows and everybody will try to follow. We are translating those rules specifically for HPMGF into our AMIS Pro. So also the non-runtime users will have more and more access to these automation rules, let's say. But actually, in AMIS Runtime, these things are scriptable already. You can already think about some smart algorithms to actually follow those the part orientation, the nesting gaps, the distances from the wall, etc., etc. So with AMIS Runtime, you could already implement those. But that's as a side note, and yeah, with AMIS, with HPMGF, but as I said, also with the other technologies, it is of course possible to translate your, I would call it almost intellectual property, into scripts. And that's also, by the way, where this becomes so interesting. This is your experience of what gives the best results, what is the best way of nesting things. And you can translate that into a script, into something which is company specific and which allows you to actually continuously upgrade your nesting performance. In other words, to continuously lower your cost per part. Now, I can imagine some people, of course, maybe you've never scripted, maybe you've often scripted things. That doesn't matter too much. First of all, because we will be very much glad to help you getting started and maybe help with a couple of scripts as well. So please do ask, because we think this is really a game changer. We want to help people on the way to actually do something with it, get something out of it, and basically hopefully, well, no, we're sure because it's installed already. Make more progress in better nesting, in better workflows with AMIS Runtime. So we want to help you with that. And secondly, because all the scripting that I'm going to show later on is made by me. And before this, I never actually wrote one single line of code in my entire life. So I don't know anything about scripting, and I was nevertheless able to come up with something that allows me to already add value to any workflow which includes this nesting. That being said, don't worry, I won't be the one doing your scripting. There will be professionals doing that, so don't worry about it. But what do we see with each of the workflows that we've been working on already? That is a certain sequence, and I think it's very very logic in a sense. You start with incoming parts. You need to go get your parts somewhere, of course, and you need to go get details on those parts, the quantities, the rotations, if they are stored. But maybe they're not stored. By the way, there's an important point on that one as well. Your incoming parts with their details. Most of the details, you might actually get them out of the analysis of the parts. The size, the dimension, the volume, the surface, etc., etc. That's available in AMIS Pro. So if you load your parts into AMIS Pro, you can actually know that already. And of course, nowadays, you can also analyze them in terms of, are they print ready? Are they acceptable? Do they need further healing? Our healing has significantly improved with the latest upgrades. And we also have a lot of feedback, by the way, on what has been happening to the part, which healing steps have been undertaken. But unfortunately, all these parts were okay, so there is not too much details here. But it basically means that if you have a yellow, or definitely if you have a red sign here, that you can assume that it will probably not print on your printer. Maybe it's possible to nest it, maybe you can manipulate it in AMIS Pro, but it's probably not going to be possible to actually print it because there are mistakes in it which AMIS Pro cannot repair. Basically, that means it's just a bad file. You need to go back to the CAT program or back to the customer because he delivered something to you that doesn't work. So, but anyway, you can analyze that part, whether it's good or bad, but also all the details about it. You're going to prepare your part. And there already, that's based on the analysis in terms of like, okay, you're going to assign a certain gap distance that it needs to keep, maybe a position, maybe a rotation, etc., etc. So maybe you're going to box it, maybe you're going to hollow it, put letters inside, etc. That can be, for example, decided upon the analysis details that you got in. Okay, so all your parts are ready, and in that sense, it follows also the AMIS Pro logic. First the parts, preparing the parts, then preparing the nest, which here is called generate. So you're going to generate your nest. And of course, without this loop cycle here, this would be perfect. It would be fantastic if it would just generate, evaluate, and then go to print, of course. In reality, and that's actually the big advantage also, is that you can evaluate and see like, this batch only comes at 11%. Why don't we try again? Why don't we try to make it 12 or 13 or 14 or whatever is possible? Or maybe a few parts are not even in the batch and the assumption was wrong. There's too many parts that actually fit inside the batch. So why don't we make a loop and try again with just a slightly bit different details or a bit less parts at the start, etc., etc. So you can, based on that evaluation, and you got a lot of data to do that evaluation, and this whole JSON export contains a lot of details. You loop and you go on. In that sense, we have users that want results fast, meaning within minutes, and they really want solutions that actually gives them a solution very fast. There might be a good plan and there might be the way you work. On the other hand, you might miss out on loops. You might miss out on opportunities to further improve. So maybe that's not good. By the way, you might also need stronger hardware then to actually deliver these solutions so rapidly. We also have users that say like, no, I'm going to do this differently. Actually, I want to put it on at 5 o'clock at night. And in the morning when I get back at 8, I want my solutions there, which is awesome, which is great because you basically can calculate all night and go through all possible solutions, which is probably a bit overdone, but you can at least go through many solutions and check everything and really come out with the best solution. So of course, this needs to be tailored to how you work and how you want it to work. But the opportunity of the loop is I think where most is to gain. Okay, you evaluate the part, you select the part or the batches that are, you evaluate the batches, sorry, you select the batches that are done, that are finished, and only last minute when they need to go to the printer, you're going to actually take them out of the system, take them out of the loop, and send them through. And that's where you release them for print. Now, we made, that was too fast. There we are. We made this one before. Some of you might have seen it, but back then, I only had 1 minute to talk about it. And I'm already, again, talking too much, so I should perhaps not go too much in detail here. But anyway, it quite follows the sequence that I showed in the previous slide, of course. And it captures a bit everything what I said also before. And first, the loading the parts, go get the parts somewhere, classifying by volume, by bounding box, by surface, whatever you need. I think that's a very important step, classifying your parts in order to divide them over different batches. Some of our users actually make classifications like 3, small, medium, large. Others make 5 classifications, extra small to extra large, which is of course a bit of a refinement, but would have an impact on how many loops you might have to go through. Etc., etc. You can start identifying bulky versus thin parts. You can also choose to leave that out in the start, of course. All these exceptions, the special ones, you can choose to leave that out in the beginning and still do some manual work at the end. That's fine, but at least 90% of the work will already be done. You can then, you know what parts you have. You can then start seeing like, okay, this one was meant for MGF, this one was meant for SLS or material or binder jetting. And of course, there will be different rules. There will be different, well, not entire scripts maybe, but a different approach to how to nest that. So that will already give you many options in that sense. And I would say there you go. You start playing around with the parts. You start saying like, okay, these are allowed to rotate, these are not, depending on X, Y, Z, on your rules, basically. You're going to center parts. You're going to distribute remaining parts so that it fills up neatly. You're going to run nesting iterations, and you can go back and loop back again as many times as you want here. So now let's see at what I have been doing, let's say. First of all, I start with the same Excel file, or my big input, my ERP system, let's say, that I have here. And yes, there are parts in there. There are rotations in there, quantities and rotations over X, Y, Z, how they should be in. In there is whether they should be shelled or not, the parts, what the shell thickness should be, and if they have a specific gap distance. Actually, I wasn't following this because basically we have decided the gap distance not on what the ERP said, but on what the calculation of the volume of the part was. So that brings me to this other point about the rotations. In reality, we see that quite often, not always, but quite often the rotations are stored in the ERP system, and that's probably a smart thing to do. I mean, yes, AMIS Pro is, or AMIS Runtime is not an ERP system in itself. But that's where you store it. But on the other hand, AMIS Pro is where you really get the feel and the view of it and really get an idea like, no, this should actually be more like that. And it's quite often the more experienced people when it comes to this manipulating these parts or what comes out of the print box later, that might be better positioned to actually decide on that. So it's instead of putting it in here, it might also be very smart to afterwards read out your JSON file and send that details back to your ERP system so that it's stored there, but that it's decided inside AMIS. Up to you to decide, just giving the idea on what is possible. Starting from here, I made a couple of scripts. And you see, I've been running them a couple of times in preparation. All went well. So this one should also be going well. First of all, and I will show you just my my entire folder. I will delete those. We remember it was 8 batches there, and that it was not so equal in density. I think right. Nope, failed to. Good. I have to restart that script. That's all. Nodes config server.js. Voila. That's where it is. I'm going to restart this one. Analyze batches. There it is. So now indeed there are no batches inside that that volume. And then I'm gonna run my first script, let's say. I'm gonna go to the place where it's located, all my scripts. There we are. You see, I've been training a lot, admit it. And I'm gonna run this main script. Enter. Basically, what it's gonna do is have a look at my CSV file, go pick up all the parts and start analyzing them and classifying them. That means it's going to check like, okay, which sizes, and I've been working with 3 sizes only, a small, medium, large. Which sizes do they have? And what is smart to actually divide those over those different batches, keeping in mind, however, our delivery dates. Okay, so based on that, it has an idea of what do I need to batch and where should it come, and it starts actually creating those batches. It's only 13 megabytes, so they're not super big here, but that's yeah, what is needed there. Anyway, you see that it's as usual quite fast, and usually, and that's also important. You're not going to sit and watch and edit anymore in reality, of course. So I'm just picking up now the batches which are being prepared here. But as they go on, we'll see that, first of all, the density will be much more equal. And so they will be all around the same density here, let's say. The fill rate will be very high. And most importantly, we will have only 7 batches instead of 8. Number 3 is in, but meanwhile, we can look at something else. because that was just I don't know who gave me the idea. It was one of the customers who gave me the idea. Let's just say, okay, a batch costs us 2,500 if it's a full batch, and of course, a lot of people are looking into scripting or answers to the question, what it's going to cost me if I can actually nest it, and not some bounding box nesting, or not just based on volume, but I want to nest a certain part, and yeah, what it's going to cost me if it's a full part. So I've got, for example, this hydroponics pump connector. I asked here for analyze selected part. Well, actually, if I would only have those parts inside my build box, then I can fit 31 in, and it's going to cost 81 euro. That's, of course, I'm running two scripts at the same time now, so it's not as fast as usual, but this is already, yeah, you can start doing that. I'll first check if it's entirely done. No, not yet. Okay. Um, so I'll wait, we'll wait because I can analyze one by one, of course. Um, but it's gonna disrupt the other one, I'm afraid. So let's not touch it. Anyway, I think most people will keep into account not only, of course, how many do fit actually when nested, and these are already keeping in mind, by the way, the rotation of the parts, so it's as it should be placed. Maybe people will also consider other things like okay, it's probably not only these parts, but maybe other ones can also fit in there. So I'm also going to have a look at the volume of the part, or the volume versus well, the outer volume versus the total volume which is taken. So this might be part of the equation. This little figure here might be part of your equation and your pricing strategy, of course, but the fact that you actually have easily access, and this easily access to the real pricing when it's nested, I think can also be an advantage in some cases. Right. Okay. Yeah, my old ones are still in. It's just restarted. Oh yeah, it restarted. Um, that's funny. I actually so gave twice the order somehow. Anyway, so this is part two, but now it actually got inside six batches in this case, not seven. I was wrong. After which it's yeah somehow I gave again the order. Must have pressed enter once too many on the other screen here. Which means, yes, you did gain. Yes, you did gain quite a bit of possibility to store more parts. You got them quicker, and you got more place to print other stuff. And I think it's not even hard to believe, I suppose. It's really like if you nest smarter, if you can divide your big parts over the different build boxes, it just makes sense that you can actually get in more parts. I'm really seem to be running this continuously somehow, but that's on me, of course. So, uh, where are we? I would say, well, back to the presentation. So it's obviously leading to higher density batches. It's obviously leading to a lower cost per part. It's obviously leading to less time spent on very manual work to do whatever. And there's and of course a better machine utilization in there. That's not just it. I give now a few examples and a few possibilities on what you can do and how you can make this loop, etc., etc. But we see already other applications like calculating the prices, because you can get all the data out of AMIS Pro. Of course, it can connect to your ERP, meaning it can become a two-way system. And I already mentioned Phasio, but we're talking to other solutions as well to actually get more connected there in order to have this two-way communication. Um, you can start, or I should say this differently. Quite often now, it's the ERP saying like, okay, you need to batch those parts because they need to be out tomorrow. You can actually turn that a bit around. You can say like, okay, pre-nest me all this, Dear AMIS Runtime, pre-nest me all this, give me the results, and then I can decide what is a smart way to go about this. You can have ERP save your rotations as managed before. You can manage your workflows. You can manage entire workflows, not just this one batch. But in the end, I've seen already customers. I made now the simple UI on top of it. You've seen it, right? I've seen other guys making already almost a new AMIS Pro on top of it and an ERP on top of it. So there's a lot of possibility there. You can, of course, report a lot per part, per build, so that can also be connected to your quality systems if you want to. You can have also over time analysis. With this data, you can start doing some real analysis, meaning you could also start looking at using AI into analyzing your nesting strategy and perhaps adjust your nesting strategy over time based on those results. So it's not just better nesting overall, let alone just better nesting of a batch, but it can go a lot beyond that. And then it's time for some prize. And I've been talking too much again. I'm afraid we won't have too much time for, like usual, for the Q&A, but still, I will try to make time of it for it. Here's the pricing. It's I think very clear. Discounts, of course, apply if you take multiple seats, multiple years. We can discuss about that one, or the rates are known there. But what it comes to for me is that if you save one build per month, meaning one out of 30 builds or 10 builds or 50 builds, if you can actually just get a bit more efficient on getting these builds filled with only a few percent, this pays back already. And then you're not even counting on the waste of time of clicking and on adjusting the quantities and the rotations, et cetera, et cetera. So I think as soon as you reach, I don't know, two medium-sized printers, you can actually make something that returns money for you on this offer. Getting started, because by now you all want to get started, of course. It's very easy, really. There's only 4 steps. We got a PDF ready, which I will actually send tomorrow together with the presentation details. So you will get that in your inbox tomorrow. But basically, it's 4 steps. You need to get AMIS Pro. We'll upgrade it to runtime for you. You need a package which is available on GitHub. You have to install Node.js and a few dependencies, but that's all neatly set in this PDF, which we will send you then. More importantly, maybe, is that it's important to get AMIS Pro, because how to understand how you go from input to output, a certain input to a certain output, or said in another way, how your IP, how you can translate that into scripts and with the right results, the ones you want to see, requires, of course, to understand how the AMIS algorithms behave. So we really suggest to get playing with AMIS Pro, to watch your results, ask us questions. Why is it that way? Why does it give this answers in this case? How can I adjust that, and etc. That's really important because that will allow you to build better scripts, of course. Just as a reminder, I would say AMIS Runtime is installed, it's operational, it's fully documented. We got people going with it, so it's not such a big deal as it may feel in the beginning. And hooray, I did manage to actually reach the Q&A. And as indicated, it might be a lot to start with, but please, if you have any questions at this point, do not hesitate to ask. You see anything coming in, Adina?
Yeah, thanks, Chris, for the presentation. Super insightful. Yeah, so if there is if there are any questions, please feel free to ask. There's a Q&A option down below in the menu bar. But yeah, it was a lot of information, obviously. Oh, there's an applause emoji coming in. But also, if there aren't any now, will be available after the webinar, of course, as well. Um,
Sure. And while I continue talking, you can still post a question, of course. That's not an issue. Perhaps we still have the time to quickly go into it. A couple of key takeaways, but I'm afraid I will keep on repeating myself in a sense. It's not about batches, or not just about batches. Of course, it's about batches, but it's about optimizing this fully complete production system. It's the entire, and it's by looking at the entirety that you gain actually the most out of it. So, and that's why this is what it is about. It's also, as said, not only about how you nest things, but when you decide that it's over, that it's good to go, that it's the time to release it. And you better postpone that as much as possible till the last minute, of course. And you can only do that if you can rely on something that gives you an answer within a reasonable time, and not that you have to restart nesting everything again. Yes, if you start, well, that's then the opposite a bit. If you have to look at one batch or a few batches only, if you optimize that one, of course you lose track of the entirety of the entire workflow, and then that creates inefficiency in that way. With AMIS Runtime, you can continuously recombine, you can improve results like that. And you go from one-shot nesting to really an iterative improvement. Because maybe I didn't stress that enough. It's not one time that you're going to go nesting. Really make use of that loop. Why not nest 10 times and 20 times and select the best option out of it? There's no limit in that sense to go through. So yeah, it can be really an iterative process, so that basically you don't look only at, of course, more efficient batching, but also quality batching, your cost, your density, etc. All in all, here the big promotion sentence: same machines, same parts, fewer builds and lower TCO. I think that hope hope that I made that obvious in this presentation. We'll be around the couple of the coming months. Basically, at the moment, there's only a meeting in Singapore planned. I'm working there also for ISO, by the way, in September. We'll be at Formnext, obviously, and in between, suggestions are welcome. We are glad to travel. We're glad to see fairs or come to your offices or whatever is interesting, because that's where it can really happen. This is one-way traffic. We prefer two-way traffic. So just let us know and just get in touch anytime. So thanks again for attending. I managed to have 2 minutes too much only this time. But I hope to meet you all soon and to talk soon. But thanks again for being here. Adinda, did I forget something?
Oh, looks very complete. Thanks so much, Chris.
Thank you very much. Talk soon.
Bye.
Bye.